All right, so we've been talking about solving systems of equations. So we've looked at solving systems of equations with graphing. We've looked at solving systems of equations with substitution. This last method is called elimination. This is probably my favorite of the three because it's just a little bit more straightforward. I think it's pretty easy and quick. And so we'll go over this one. So when we're talking about elimination, we're thinking about the word eliminate. To eliminate something means to get rid of it, right? So our whole goal is to eliminate one of our variables to solve for the other one. So we'll do some practice on it. I think it'll make sense. So what we're really going to be looking at when we're looking at systems of equations, particularly with elimination, is we're going to really pay attention to the coefficients. And the coefficient is the number before a variable. Right, so an example of that would be like 2x or negative 7y, right? So a coefficient is the number that comes before the variable. So our coefficient here is 2. Coefficient here is negative 7, right? So the coefficient is a value that comes before our variable. We have two separate ways of solving systems of equations with elimination. One of them involves adding the two equations, and then one of them involves subtracting the two equations. And so there's specific circumstances that we do each. So if I'm going to solve a system of equations by elimination using addition, what I want is for the corresponding variables with opposite signs. So here's what that looks like. I could have the equation, I don't know, 2x plus 3y equals 4. And then the equation negative 2x plus, 5y equals negative 7. Okay? So here's what I'm talking about, corresponding variables. So here are my corresponding variables, or my x's in this case. Okay, I have 2x and I have negative 2x. So my corresponding variables have opposite signs. When that's the case, I'm adding these two equations. I'm adding them together. The reason I do that, right, is if I add 2x plus negative 2x, cancels each other out, eliminates them, becomes 0. If I were to subtract these two, 2x minus negative 2x, so if I had a 2x minus a negative 2x, well, I know that if I subtract a negative, it becomes a positive. Now I have 4x. That didn't do me any good at all, did it? No. So in this case, I'm going to want to add them so that they cancel each other out. So then if I'm subtracting, in that case I would want my corresponding variables. I'm looking for corresponding variables with the same sign. Okay, so that would look like this. If I had 3x plus 2y equals negative 4 and 3x minus 7y equals 2. Okay, here my corresponding variables are still my x in this case, and they're both positive, right? I have a 3x and a positive 3x. So in this case, in order to get rid of them, I need to subtract. Okay, so I'm going to take my first equation minus the second one to get rid of it. Okay. I have some steps here for solving equations by elimination. Again, kind of like with substitution, I'm not going to really go over these word by word right now. We'll just kind of do it, and then these steps will make sense once we kind of start doing a couple examples. So here, our first example is by adding. So if you notice, right, I have my corresponding variables my corresponding variables here are 2 and negative 2. Here they are. And so my corresponding variables have opposite signs. That means that I need to add these two together. So negative 2x plus 2x is just 0. Then I have 3y plus a negative y, or 3y minus y. So I have 2y. And then 4 plus negative 8, or just 4 minus 8, is negative 4. Divide both sides by 2. Just have y equals negative 2. That's it. Super straightforward, super simple. Now that I have my y value, I can plug it into one of my equations to figure out what x is. So I think I'll use let's use the second equation. So then I would have 2x minus negative 2 equals negative 8. If I subtract a negative, it's the same thing as adding. So then I would subtract 2 from both sides. 2x equals negative 10. Divide both sides by 2. X equals negative 5. So then the solution to this system would be negative 5, negative 2. That's it. Like, it's super simple. Super simple. Let's look at the subtracting one. Okay? I'm going to solve these by subtraction. I'm looking for my corresponding variables. My corresponding variables happen here. Okay? They're both positive, so I'm going to subtract these now. So 3x minus 3x is just 0. I'm not even going to write anything. I'm just going to say that's 0. 2y minus negative 4y. If I subtract a negative, it's the same thing as adding. So this becomes 6y. 4 minus 16, negative 12. If I divide both sides by 6, I'm left with y equals negative 2. Okay? Now, I'm going to take my y value and plug it back in to one of my original equations. Let's choose the second one, because I picked the first one before. So I would have 3x, 3x minus 4 times negative 2 equals 16. So I would have 3x minus negative 8 equals 16. These become positive. So we'll subtract 8 from both sides. Get 3x equals 8. Divide by 3. X equals 8 over 3. Now, I'm sure that some of you are going to stop and look at this and go, that doesn't seem right, right? Why did I get a fraction as an answer? Well, fractions are not bad. Fractions are not wrong. I think that for a long time you've kind of been taught to divide fractions out, but they're so much easier to work with if we just leave them as they are. So there's one foolproof way of checking to make sure that your answer is right? So I got the solution 8 over 3, 8 thirds, negative 2. If I wanted to test this out to make sure this works, all I need to do is plug these into one of my equations to see. So I'm going to plug it into the first one. So 3 times x is 8 over 3 plus 2y, which is negative 2, should equal 4. I want to know, is this accurate? Well, if I did 8 over 3 times 3, these cancel out, so I just have 8 minus 4 equals 4, and I know that that's true. 4, if I add 4 to both sides, right, I get 8 equals 8. We're good, right? That takes all of about 10 seconds to plug your answers in to see if they're right. So if you get a solution like this and you're just not sure if that's accurate, plug your numbers in and check. That's a good practice to get into anyways, because you want to make sure that your answers are right, especially on a test or something, right? So if you're uncertain about it, make sure you just plug them back in, and then you can be sure about it later. Okay. That's all fine and dandy. We've done examples where my coefficients are the same out of the gate, right? That's not always going to be the case. So I may need to do some manipulation in order to do what I want to do with elimination. So if I look at this system of equations, I have 3x plus 2y equals negative 2, negative 6x minus 5y equals 2. Well, I don't really have any that are matching right now, right? But what I have noticed is that these are really close, right? 3x and negative 6x are very, very similar. So what I can do is I can manipulate my first equation so that it matches the second one. So the way that I would do that is I'm going to multiply this whole thing by 2. I can't just multiply part of it by 2. I can't just multiply the x by 2 to make it the same. I have to multiply the whole thing by 2, and I'm going to show you why. So when I do that, then I'm going to have 6x plus 2, oh, nope, see, I almost did it. 6x plus 4y equals negative 4. And then on the bottom, I still have negative 6x minus 5y equals 2. So I'm going to pull up Desmos, and we're going to look at this. So here's our equation right now. As is, we have 3x plus 2y equals negative 2. So I almost made the mistake the first time that I wrote this out of just changing the first one. So if I just changed the 3x to be a 6x, it's not going to look the same, and I'm going to show you. So I would have 6x, and if I left everything else the same, plus 2y equals negative 2. If I did this, now they are no longer the same line. Do you see that? Now they're different lines, and that's not what I want. What I want is to be able to change it so that the line stays the same. So in that case, what I have to do is I have to make sure that I multiply the whole thing. So if I multiply the whole thing by 2, I have 6x plus 4y equals negative 4. Now I have the same line. See, it just drew the line on top of the one I already had. These are the same line. It's the same equation. So when I come over here and I multiply the whole thing by 2, I'm not changing this first equation. I'm just rewriting it in a way that's useful to me, right? So I'm not changing anything. It's the same line. I just kind of rewrote it so that I can work with it. So now I have corresponding coefficients that have opposite signs, which means that I'm going to add these two together. So 6x minus 6x, that just becomes 0. 4y minus 5y is going to give me negative y. Negative 4 plus 2 is going to give me a negative 2. So if negative y equals negative 2, that means that y equals 2. Now I can just plug these back in. I'm going to use the first one. So 3x plus 2 times 2 should equal negative 2. So 3x plus 4 equals negative 2. Subtract 4, I get 3x equals negative 6. Divide both sides by 3, x is negative 2. So my solution here would be negative 2, positive 2. All right, I want you to try this next one on your own. Here, I'll go back up so you can see what happens up here. Okay, I want you to try this next one on your own. So obviously I can't just start adding and subtracting right away. I have to do some manipulation. So figure out which one of these you need to multiply by something, and go ahead and solve for x and y. When you're done, go ahead and start this video back up and you can see how I did it here. All right, so when you go ahead and solve all of this, you should have gotten to the point of the solution of negative 1, negative 1. We wanted to multiply the bottom equation by 2 and then solve from there. So go ahead and check your process, your solution with mine, make sure that you got that. And we will move on to the next page here. All right, real life example. So a business with 2 locations buys 7 large delivery trucks and 5 small delivery trucks. Location A receives 3 large trucks and 2 small trucks for a cost of $270,000. Location B receives 4 large trucks and 3 small trucks for $375,000. What is the cost of each type of truck? All right, when I look at this, I want to pick out the important information. So here I see that location A, all of the information with location A is here. If I want to look at the information for location B, all of my information for location B is right here. So that's my important information. Next, I want to designate which truck is which variable. So I'm going to say that the cost of a large truck is X and the cost of a small truck is Y. So if I do that, then I'm dealing with location A over here. I would have 3X, I have 3 large trucks times however much each of them are, plus 2 times Y, 2 small trucks times however much money a small truck is, should equal $270,000. That's my total cost. Do the same thing with location B. I would have 4X plus 3Y equals $375,000. All right, so as is, I don't have variables that I can eliminate, but there are some pretty easy options that I can do. Here's what I'm going to say, is that it's easier to work with smaller numbers than larger numbers, right? So I've had a lot of people look at, well, the 3 and the 4, I can just multiply the top one by 4, the bottom one by 3, and we're good to go, which you can do that. That works. It just ends up being some big numbers, and I don't really want to work with big numbers. So the ones that I'm going to focus on are the Y values in here. Okay? So what that means is I'm going to multiply this top one by 3, and I'm going to multiply the bottom one by 2, so that my Y values are both 6. So here's how this works. Ready? We're going to multiply this whole thing by 3. So I have 9X plus 6Y equals, when I have big numbers like this, I just focus on the smallest parts of them. So my smallest part is 27. So if I do 27 times 3, that's 81. But I have 270,000. So it's going to be 810,000 is my top one. And then if I multiply this bottom one by 2, I have 8X plus 6Y equals, same thing here, if I did 375 times 2, it's 750. So this is going to be 750,000. So now I have corresponding variables right here, my 6 Y's. This is what I want. So now, if I want to get rid of them, what I need to do is subtract these 2 equations. So here's what happens. My Y's go away. 9X minus 8X is just X. And then I'm going to take 810,000 minus 750,000. Again, I'm just going to look at 810 minus 750, which is going to give me 60. It's going to be $60,000. Now if I want to figure out my Y values, I'm just going to take 60,000 and plug it in. So I'm going to plug it into the first equation. So I would take 3 times 60,000 plus 2Y should equal 270,000. I'm running out of space, so it's just going to look like that. So then 3 times 60 is 180. So I have 180,000 plus 2Y should equal 270,000. Now I'm going to subtract 180,000 from both sides. Here's another one. We're just focusing on the smaller numbers is useful, because then I'd have 2Y. Then if I just did 27 minus 18, that's 9. And then I have the rest of the zeros still. Divide both sides by 2. I'm left with Y equals $45,000. Okay, so in this situation, you can list this as an ordered pair, like we normally do when we're dealing with systems of equations. The question is asking, what is the cost of each type of truck? So as long as you have labeled that, well, my X values are my large trucks, my Y values are my small trucks, and this is what you show me, then you'll be fine. I'm okay if you just leave it like this. But you have to make sure that you tell me which is which. Otherwise, it's not really an accurate answer. Okay? All right. So I hope that elimination feels pretty straightforward to you. Here's the thing with it though. So I love elimination, but it's not always going to be our best option. So we have to use some critical thinking skills to figure out which option is going to be the best in our scenario. So if I look at these, my first one, I have 3x plus 2y equals 4, and 2y equals 8 minus 5x. So if I want to use elimination, what I'm really kind of looking for is either two variables, like the same variable that has the same coefficient, that is ideal, or a variable that can easily be manipulated to be the same. So as I'm looking at this, I'm noticing that I have a 2y here and I have a 2y here. So I would say that this is best to use elimination, and here's why. I would write explanations here because then you'll know why it is that you chose which one you did. So I would pick elimination because I have the same coefficient with the y variable, right? So I can easily eliminate y. Okay? Whoops. So then, if I look at the next one, I have negative 6y plus 2 equals negative 4x. Y minus 2 equals x. In this case, I would use substitution. And here's why. In substitution, what I'm looking for is I'm looking to solve for one of my variables so I can plug it into the other equation. Well, I have x already solved for in this case. So I would use substitution because I can plug y minus 2 in for x easily. Right? It's already done for me. So I would pick substitution in this case. So if we look at the next one, y minus x equals 2, and y equals negative 1/4 x plus 7. Here's another one where I would use substitution. It takes a little bit of manipulating, but not really much. I would add x to both sides. So then I would just have y equals x plus 2 over here. So I would do that because then I could plug x plus 2 in for y easily, right? So this would be the best option for this one. Now this last one, 3x plus y equals 1/3, 2x minus 3y equals 8/3. Here's what I'm noticing here. I have a y and I have a 3y, right? A negative 3y technically. And so I could solve for y pretty easily with the first equation. I could. But there's a lot of fractions in there, right? And I don't really feel much like plugging fractions into fractions all the time. So here's what I would do, is I would notice, well, I could multiply this top one by 3. So then I would have 9x plus 3y equals 1. In this case, elimination is the easiest. Right? I would multiply times 3. Let's see. Let's do this. I would multiply first equation by 3 to eliminate the y variable. Right, so elimination is going to be the easiest in this case if we manipulate that first equation so that we can cancel out our y values. Okay, so that is all then for 5.